Hello, welcome to this topic on design data requirement. At the end of this topic, you will be able to describe distribution planning, explain short-term planning, explain medium-term planning, explain long-term planning, explain design data requirement. Let's start off with the distribution planning. With different goals in mind, with different requirement to fulfill, distribution planning can be done in different ways. This planning involves for which period this plan is made. In the planning process, what are all the activities specific required, execution of the plan. The distribution plan discussed previously may be one of the following types with reference to the duration. It can be a short-term plan, it can be a medium-term plan, it can be a long-term plan. For proper distribution planning, the study of the existing system to ascertain loss level and decide on immediate action to be taken is required. Short-term planning is carried out to immediately resolve the issues in the distribution system to ensure an uninterrupted power supply. The main objectives of this type of plan are to develop specific case studies and projects in a systematic manner, adjust capacity of 33 kV, 11 kV feeders, power transformers, distribution transformers and LT lines, take immediate action to bifurcate heavily loaded 33 kV, 11 kV feeders, augment the line with properly sized conductors, reduce the length of LT lines maximum 0.5 km per transformer. In the distribution system, usually medium or long-term type of planning is carried out. The reason is that it is part of the master plan. The time frame considered will be around 5 to 15 years depending upon the state or the national or the local forecast of the load, agricultural load forecast and plan of industrialization. The existing capacity of the lines to be reconfirmed, the existing capacity of the substations to be reconfirmed, the additional capacity requirement to be reconfirmed, finalize and arrange for contract for additional power purchase, arrange and augment the existing transmission line capacity, technical losses, find out the reasons for this, plan and arrange for reduction of the same, prepare the cost estimate or budget and arrange for the funds. Now let us learn more about the design data requirement. Distribution system planning starts at the customer level. The data regarding the demand, type, load factor and other customer load characteristics dictate the planning of the distribution system. Let's look at the data required for the planning of a distribution system for supplying the power to 5 villages. Let us consider 5 villages lying very close to each other as shown on the screen. These villages have to be electrified. The location of the nearby substation is also denoted and the load requirements for each village has also been denoted. Now let's calculate the load requirement for each village. For village A, present calculated load is 380 kVA, future load is 700 kVA, total provisional load is 1080 kVA and planned load is 1250 kVA. Next, for village B, present calculated load is 500 kVA, future load is 500 kVA, total provisional load is 1000 kVA and planned load is 1250 kVA. Next, for village C, present calculated load is 450 kVA, future load is 500 kVA, total provisional load is 950 kVA and planned load is 1250 kVA. Next, for village D, present calculated load is 200 kVA, future load is 500 kVA, total provisional load is 700 kVA and planned load is 1000 kVA. Next, for village E, present calculated load is 290 kVA, future load is 600 kVA, total provisional load is 890 kVA, and planned load is 1250 kVA. And for all villages, present calculated load is 1820 kVA, future load is 2800 kVA, total provisional load is 4620 kVA, and planned load is 6000 kVA. As previously discussed, the substation is available for catering the load requirement which is indicated in the earlier map displayed. Arrival of the load calculation is described here below. Collect the total present load requirement of each village and consolidate. Depending upon the past history and based upon the future plan for the next 10 years, assess the future load requirement of all the 5 villages. Add both the load requirements, present and future, and arrive at total requirement. Whether any distribution substations 33 or 11 kV are available nearby. Click the arrow on the right side to move on to the next. In between, if you want to go back and take a glance at the previous sections, click the arrow at the left end. Check whether the available substation have provision to add on loads to the extent of power requirement of the 5 villages. If not, whether it is possible to augment the power in the distribution substations 33/11 kV. If the answer is yes to both 5 and 6, whether the power can be transmitted at 11 kV level. If yes, whether the distances of the villages from such substation lies within the permissible limits as prescribed by the competent authority. If yes, then after getting the approval from the competent authority, activities from the survey to be started and estimates both time and cost need to be prepared. Such an estimate needs to be converted into the budget so that the balance activities for implementation can be started on approval on budget. The load for each village in the picture now represents the total load as discussed previously. Let us consider 5 villages lying very close to each other as shown on the right side. These villages have to be electrified. The location of the nearby substation is also denoted. The substation available nearby is loaded to 90% of its capacity. To supply the required power, we need to construct a new substation. In scenario 2, a new substation is required for catering the load requirement. For the new 33 kV line and MV substation, we need to work out the following. Identify a suitable land, preferably owned by the government for the construction of 33/11 kV substation. If the above is not available, then identify the land which needs to be acquired and initiate the process of acquiring. Identify from which transmission substation line need to be drawn for the new 33/11 kV substation. Initiate survey for the new 33 kV line and prepare the estimate. Click the arrow on the right side to move on to the next. In between, if you want to go back and take a glance at the previous section, click the arrow on the left end. Prepare the estimate for 33/11 kV substation. Prepare the estimate for 11 kV outgoing feeder lines. After getting the approval from the competent authority, activities from survey to be started and estimates both time and cost need to be prepared. Such an estimate needs to be converted into the budget so that the balance activities for implementation can be started on approval of budget. Check for substation availability. Scenario: 33 kV line for the new substation is not available. Land identified. Incoming can be tapped from 33 kV substation from 12 km for a power of 10 MVA. Estimate for feeder: 12 cubic kilometers of 33 kV lines, 33/11 kV 2/5 MVA substation with 1 incoming feeder and 12 outgoing feeders, 11 kV lines, DTRs and LT lines as required based on survey.